100 webinar. Like Heina said, my name is Gwendoly Espe, and I'm an applications engineer here at OutBack Power. And today we're going to be talking about the benefits of the FM100 from our other products and other types of charge controllers. So let's just get started. All right, so these are our topics that we will be covering today. We'll do an FM100 overview. Then we'll go over string sizing and other advantages of the FM100 has to offer. Then we'll explore the rapid shutdown and how the system is set up with the new FM100. And then we'll wrap up with some questions. So the FlexMax product line includes the FM60, which is our value product, FM80, which has been around for a while now worldwide and is really a solid performer. And now we have the FM100, which is our premium flagship product. It increased energy harvest and performance and reduces system cost and installation. And we'll go over all of that stuff. So see, here we have the high level product specifications within the FlexMax product line. The FM60 150 volt DC is a 60 amp 150 volt charge controller. It has an internal cooling fan and is fully compatible with the Mate 3 product line. Then we have the FM80, so 80 amp 150 volt charge controller, and it has a top mounted cooling fan for easy access, and also is fully compatible with the Mate 3 product family. And then we have the FM100, 100 amp, 300 volt charge controller. It has enhanced MPPT algorithm for improved harvest. It has active cooling, and something to note is it's compatible only with the Mate 3S. You need a Mate 3S for this product. That's what that means. So the old Mate 3 is no longer in production. Access port can also be used instead of a Mate 3S for Modbus control or Optics RE monitoring control software. This product is outdoor rated. It has the same enclosure as the FM Extreme. This enclosure might look a little familiar, and that's because it's the same as the FM Extreme. It also has a built-in ground fault protection and is field upgradable. That's really nice. All right, so here is a feature summary. So lower system costs by reducing component count, complexity, and installation time. It's engineered for reliability, so we've done extensive quality and reliability testing, including high accelerated life cycle testing or HALT testing. It's outdoor rated NEMA 3R enclosure. It's also IP54 ingress rating, and it comes with a 5-year warranty. It meets NEC 2014 and 2017 compliancy. We have rapid shutdown functionality is included with this, and we'll go over that later. And it also has internal ground fault protection. And like I mentioned before, the new MPPT algorithm increases the energy harvest. So it quickly achieves the cell state in a grid connected system, and also charges batteries faster in an off-grid system, which is great. All right, so we'll just go over kind of quickly the specifications. I don't want to drag this one out. So we have nominal voltages of 24 volt, 36 volt, and 48 volts. The maximum continuous input, so the PV side, is 64 amps. And the maximum continuous output to battery side is 100 amps. The max PV per circuit voltage is 300 volts, and this is before the possibility of equipment damage. So you can perform this all the way up to 300 volts. The operating voltage is up to 290 volts. So between 290 volts, just something to know, and 300, it will be silent. Some competitors have said that they have a 300 volt charge controller, but they also only operate up to 250 volts and are silent up to 298. So we're actually operational all the way up to 290 volts, and then up to 300 before you might be risking some equipment damage. So it's a very efficient system with an average efficiency of 96% and a peak efficiency of 97.5 for 24 volt system, and then an average efficiency of 97 and peak efficiency of 98.8 with a 48 volt system. The FM100 has accessory terminals with added functionality, including rapid shutdown confirmation, auxiliary relay, and battery sense, which we'll talk about later. It is outdoor rated. Ground fault is internal to the charge controller. Operating temperature is -25°C to 60 degrees Celsius. The LED indicator displays what mode the charged controller is in, whether it's in float, GT mode, or low battery. So that will let you know what state the charge controller is in. And there's also the two new LED features, which is a rapid shutdown and also GT mode, which is grid tied mode. So if you want to have a remote interface, the charge controller uses Modbus on spec through the access port as its communication protocol, and it is optics RE compatible. And then a little larger, so that the enclosure, the dimensions, is a little bit larger than the 60 or 80 amp charge controllers, and it's pretty much the same as the FM Extreme. And like I mentioned, has a 5-year warranty. All right, so the FlexMax 100 has increased energy harvest. So we updated the board layout and the mechanical design that allows for more power to be produced. So we have an expanded input operating voltage range from 20 volts to, that should be 290 actually. So I don't know why that says 300, but from 290, that's the operating voltage range. We have active cooling. And typical efficiency, like we went over, is about 97% with peak efficiency at 99%. And we do have the industry-leading MPPT algorithm at 99% efficient. So the FlexMax 100 puts OutBack in a unique position. So the FM100 is up to 300 volts and enables 2-string arrays to reduce the balance of systems, or BOS, and installations cost. So according to NEC, PV arrays consisting of 1 to 2 strings do not require fusing on the PV output circuits. All you need is a Y connector. So the 100 amp output current allows for higher power modules and arrays. Some have the amperage and some have the voltage. OutBack has a 5 kilowatt power available at both our operating voltage and current. So we have both the voltage and the current. So we're going to go over an example. So some people ask, well, why doesn't OutBack have a 600 volt system? Well, it is due to the power constraints. So with a 80 amp charge controller, increasing the PV voltage won't optimize the system, and here's why. So like I said, we have an 80 amp charge controller, and with a nominal voltage of 48 volts. So that gives you, so you'd have a maximum power output of 3,840 watts. So 3,840 watts is the maximum that charge controller can output. Even if you are at a higher voltage due to charging, that would put you, a little bit over 4,000 watts. So using a 320 watt module at 40.8 volts VOC, we can have up to 14 modules in a series. That puts us at 571.2 volts. Now remember that the maximum output on this side, right, is 3,840 watts. So in this example, with the 14 modules, you could have output 4,480 watts on the PV side, but you're limited to the 3,840 due to this 80 amp output. So essentially, an 80 amp 600 volt controller, they're like larger, they're expensive, and in this case, they'll produce less power to what's available, not more. So moral of the story is an 80 amp charge controller, whether it's 300 volts or 600 volts, is still a 4 kW charge controller and may actually produce less power, not more. So all of the users' accessible ports and terminal blocks are shown here. So this is the internal of the charge controller. The hub ports, so you can see here, the hub ports connect with the communications with the rest of the system. Or if you have just the charge controller and Mate 3S, this is where you would connect your Mate 3S. The 2 ports here are for future expansion. We have our micro SD card. This is how you would do a firmware update. Even if you're using a Mate 3S, you still need to have an SD card in the FM100. It utilizes that SD card to do a firmware update. And don't worry, every unit will come with a micro SD card. And then here we have the ground fuse and the DC to ground jumper, which we'll be talking about next. So this back here, you might not be able to see this black block back here. This is that ground fuse. And then this, obviously you can see the jumper. And something to note too is that this is your reset button. So if you were to do a manual firmware upgrade without an interface or without a Mate 3S, you could also do that manually. And that will be in the manual. All right. So the GFDI breaker provides that ground between the DC minus and the ground. So you want to leave this jumper in place for a single FM100 install. But when you have multiple units, you need to remove the fuse and the jumper on the second to the last charge controller. But you need to keep both on the first charge controller. So essentially, in a system, you want to have one charge controller that has a fuse and that jumper. You want to ensure that if you have multiple charge controllers, that you remove it on the rest of the charge controllers. So, however, if you want to float the array for some reason, then you would have to remove the jumper, this ground jumper. For example, it's possible for a positively ground system, you would, if you want to design a positively ground system, you would pull this jumper and use an external DC plus to ground. So for rapid shutdown, you would use terminals 1 through 4. Terminals 1 and 2, so these yellow terminals are common, they're connected, and 3 and 4 are common. So they're the same node. You will still need the RSI shown here to initiate a rapid shutdown event. And we'll go over this probably several times throughout this webinar. So if you didn't get it the first time, don't worry, we'll talk about it again. So if you have multiple FM100s, so actually let me talk about this. So like I said, 1 and 2 are common, 3 and 4 are common. So you'd still need an RSI to say, hey, we have a rapid shutdown event. And essentially 1 and 3 are your communications lines. So this sends the signal to the charge controller that, hey, a rapid shutdown event has occurred, shut down. And then 2 and 4 are used to daisy chain multiple charge controllers. So it ensures that charge controller B, C, D all get the same signal. If you don't need, let's see. So if you don't need a rapid shutdown, you would install, so for some reason you don't need rapid shutdown, you just need to make sure you install a jumper between 1 and 3 or 2 and 4, between the yellow and the purple, essentially. All right, auxiliary port on our charge controller. So some auxiliary functions have reverse functionality, meaning that it can be programmed to be 0 volts initially and then output 12 volts under the qualifying condition, or it can be reversed, meaning 12 volts initially and then output 0 volts under the qualifying condition. I think we call it reverse polarity, even though I don't think that's technically, that can be confusing. But so there's a lot of different functions. So we have the PV trigger, we have error output, we have night light, low battery, rapid shutdown, etc. I think we have up to 10 now, 10 different auxiliary functions. So this is the terminal block we talked about earlier, 1 through 4. So, so this is just an example to show how you would connect rapid shutdown. So we also have a rapid shutdown functionality auxiliary, but it's not required. And if you'd like more information about the rapid shutdown, it's called the rapid shutdown confirmation. That part is not required. But if you like more information, it will be in some documentation in the future. But this is just showing how you would wire up pretty much what this looks like within the RSI. So you have nodes, you have the second and fourth in this case connected to J3. And this gives that signal to, and this is a dry contact, and this gives that signal to the charge controller that a rapid shutdown event has occurred. All right, so I think that's it for this. So we have lots of auxiliary options. Lastly, in the auxiliary terminal block, we have battery sense leads. So what can happen when you have multiple charge controllers in operation is that they read different voltages from each other. And this can happen if you have main power conductors of different lengths, or if you have different currents going through the conductors at the DC terminals on the charge controller. So one charge controller might say, oh, this other charge controller is putting out higher absorbed voltage. I'm only allowed to go up to 57.6 volts, so I'm just going to go offline. So then it will go into silent mode, and you're not really effectively using your charge controller, right? So you can overcome this by either, by calibrating your charge controller. So that's one solution. And that process is, you put a voltmeter at the battery bank terminals and then calibrate each charge controller to that value. And that's one solution. But another solution is that now we have the battery sense leads on pin 7 and 8. So this is black and red terminal. So you can daisy chain, so essentially it's a voltmeter on the battery bank. So now it's reading the actual voltage from the batteries with very low current, so there's not a voltage drop. You don't have to really worry about that. And you could daisy chain this to your other charge controllers. So now you don't have to worry about, like I said, voltage drops since the battery sense circuits are very low amperage. You don't have to worry about a charge controller dropping offline prematurely. It's a really nice feature to help the array produce more and more often. All right, here we're going to take a look at different charge controllers using a 320 watt module or modules and 40.8 volts VOC. So for the FM80 with a 150 volt max, we can only have 3 modules in series, which means up to 4 strings. And the associated BOS that with it gives you 3,840 watts. All right, another example, another type is a 100 amp, 240 volts charge controller. So with the 240 volt limitation, we can have up to 5 modules in series and 3 strings. And that would give us 4,800 watts. Another example is a 55 amp, 250 volt charge controller. Something to note, what's interesting is that this charge controller says 250 volts plus battery voltage, but their voltage above 250 is not operating. It's a safety zone. So the FM100, however, operates up to 290, where this charge controller operates up to 250. So now think back to so for this charge controller, the max, right, is 2,640 watts. And this is, so now let's think back to that example I had earlier about higher voltage doesn't always mean higher optimization. So here we have 5 modules in series, right, with 2 strings, which would be normally 3,200 watts. So we have 5, all of this would be about 3,200 watts from the PV side. But due to the 55 amp limitation on the output, with a 48 volt nominal system, this power gets curtailed down to 2,640 watt output. So that's the maximum it would be able to produce due to this 55 amp limitation. And that's the same, let's go back up here. That's the same thing that we were talking about here, this 80 amp limitation. So when you have an 80 amp charge controller, just multiply that by your nominal voltage or the voltage of your battery bank, and that's going to be your power output. Okay. Oops. So the FM100, which operates up to 290 volts and it has 100 amp output, gives us 4,480 watts with 7 modules in series and a total of 14 module array. Now compare this to a 15 module array with the second example. With the FM100, you've reduced the need of fuses, so you just need a Y connector and other BOS. So it's easier with the 2 strings and a more cost-effective system, and the only difference is 1 module. All right, so OutBack's ICS Plus is the first fully compliant rapid shutdown system. It's specified as a PVRSS, so PV rapid shutdown system, and other competitors might be listed as a PVRSE, a PV rapid shutdown equipment. So the SS is a UL certified solution where SE assumes the liability on the designer, the installer, and the HJ for everything to be done correctly. So the SS, the PVRSS here, is a fully listed compliant solution. You don't have to worry about it. It has a stamp of approval. So for the arc fault, we have done extensive testing. We've done testing with electronic ballast, compact fluorescent light, light dimmers, worst case scenarios, and we could not get the arc fault detector to falsely trip. So we did a lot of testing to make sure the arc fault wouldn't do that. My colleague even went as far as loosening up a terminal and then move the wire inside enough to get a spark, and he finally got it to trip. I don't recommend it. I'm just telling you what he did to test it. Second is our rapid shutdown system. So it includes the RSI, and the combiner, which has the contactor, the arc fault, the local disconnect, etc. And the disconnecting means. So this is the RTB, the remote trip breaker. We'll go over that a little bit later. And then we have that local disconnect as well. So this is our total compliance solution. All right, I don't want to go too in depth with this slide, but so here's a system diagram of our current rapid shutdown solution. We have the array on the roof that runs to the combiner box. The roof is kind of small in this diagram, so normally the combiner box would be much closer, and these lines, some of these lines, the length of these lines would be actually running on the roof, and that's what is being addressed in this rapid shutdown. So within the combiner box, there is a arc fault detector, so in this guy, and a contactor that disconnects the conductors from the combiner to the charge controller in an arc fault event or rapid shutdown event. So it's essentially, shutting down these conductors here between the combiner box and the charge controller. So on the FM60 and 80, the capacitors did not charge fast enough so that the same conductors could still be hot. So we had a remote trip breaker that opened up these conductors. So in a rapid shutdown event, our capacitors could not bleed down fast enough. So essentially, even if this combiner box disconnected the PV array, our charge controllers could backfeed some voltage, some energy back into this line. So that's why we had this remote trip breaker to also break off these conductors from the charge controller. At the ground level here, we have the RSI, the rapid shutdown initiator that sends a signal up to the combiner and then also sends a signal to this remote trip breaker. And that's how our ICS Plus solution works. So let's take a look inside the combiner box and the wiring. So note, this is what the combiner box would look for would look like for the FM80 and the 60. The FM100 will look a little bit different, and we'll go over that in a little bit. So here you can see the PV strings entering the combiner box to the fuse. Right now you can only see one, but you could do up to 6 strings. After the fuse, the conductors pass through the arc fault detector up to the contactor. And this is where the PV gets combined and gets sent to the charge controller. So it goes through the contactor down to the charge controller. Here we have our arc fault detector. So like I said, we had tested this very extensively to make sure that it did not, or so that we knew, or so that it would not nuisance trip or have a less likely chance to nuisance trip. And also this contactor is a really stout and reliable DC contactor. It will activate under 3 conditions. So it activate through this local disconnect. So here's our board, and this is kind of the logic or where everything's controlled with. So we have a local disconnect here on the right-hand side, sends a signal to the board, and then that would open up this contactor. Or if there's an arc fault event, it will send a signal to the board and then open up this contactor. Or if there's a rapid shutdown, so if you were to turn this knob and say, hey, we're in a rapid shutdown event, it would send a signal up to this terminal block and also do a rapid shutdown or open up that contactor. I apologize, I was coughing. Okay. So this is the rapid shutdown initiator. So this is your solar on, so this green LED would be lit in a normal condition. And then once you have a successful rapid shutdown, if you were to turn this off, then you would have your solar off LED illuminate. If there is an AFCI event, you can reset it from the ground floor using this RSI here. So you just turn it off and then back on. On the combiner box itself, it will illuminate. So you have multiple combiners that can identify which box detected the arc fault. So here we have an LED. So if you have multiple combiners and there's an arc fault, the combiner box that had detected that arc fault will actually illuminate. So you can narrow down which combiner box had the issue. If for some reason it was not a nuisance trip. All right, so this is what's inside the RSI. We're just going to focus on this auxiliary terminals. So J3, so this goes to the FM100, telling the FM100 to perform a rapid shutdown. If you were to have a rapid shutdown along with an FM100. J4 is what you could do is an optional confirmation that the RSI says status from the external rapid shutdown device. So this could be, if you're using an external device and you wanted to get some type of confirmation that yes, that device had successfully shut down or opened up some conductors, you can get confirmation. And we have a auxiliary option that is rapid shutdown that could also, you could connect to this, but that's an optional thing. J5 is an alarm or other component that an AFCI event has occurred. And then finally, J6 is trip from another switch inside the house. So for example, you could use optics RE and an unused auxiliary relay port to clear an arc fault remotely. So this is basically a rapid shutdown initiator from some type of external device. So essentially, you can instead of physically turning off the switch, you could do that through this J6. And so what this is saying is that if you had some other type of auxiliary terminal along with this guy, and there was, for example, a nuisance trip for some reason on the AFCI, you could remotely clear it through this J6. Another example is you could connect this to, for example, a fire alarm system. So if there was a fire, it would automatically initiate a rapid shutdown event. Okay, so here is the comparison. So this is where we get to the meat of things, where everything comes together. So here's a comparison of the FM80 and the FM100 with the ICS Plus system. So first, let's walk through the FM80. We kind of walked through this already earlier, but we'll just go over it again. So here we have the PV strings. Here we go. Yep, that go into the combiner and through the fuse. And then it goes through the AFCI and then combined at the contactor. This is the line here between the contactor and the charge controller that has to be less than 30 volts in 30 seconds, I believe. Now remember, on the FM80 and 60, the capacitors did not discharge fast enough, so that the same conductors, so if you didn't have this here, this charge controller could backfeed this conductor and cause it to still be hot. So that's why we added this remote trip breaker, so that it opened up those conductors. The control system here is ran from 24 volts, 24 volt source. So with this breaker control, that's what this name, this name is breaker control. This was a power source, so it could take 24 volts or 48 volts, and then it will output 24 volts for this system. The breaker control also gives a signal to the remote trip breaker to open up the rapid shutdown condition. In this system, you also need a GFDI breaker on the output side of the charge controller. So not only did this breaker control provided the 24 volt power for the system, but it also sent the signal. Its responsibility was also to send a signal to the remote trip breaker to open up. So now let's look at the FM100. So we can now bring two strings into a Y connector. You can assume that here is a Y connector. And then pull the conductors through the arc fault detector, because we still need to do arc fault. And then to the contactor, and to disconnect the power between the array and the charge controller. Note that we don't need a remote trip breaker, because now the FM100 input can now achieve less than 30 volts in 30 seconds. So we also don't need a GFDI. We can use a normal 300 volt rated circuit breaker, but we still need to provide the power to the control system. So instead of a breaker control, so instead of this guy here, there are some low cost power solutions for around $30. So inside the FM100 too, we have a rapid shutdown function, and that's what takes place of the logic side of the breaker control and the RTB, the remote trip breaker. So it's a lot simpler solution. Yeah. So bottom line is there's no fuses, no GFDI now since it's internal, and no breaker control. You can just use another power source. It simplifies the design and lowers the overall cost. All right, so we have our later in 2018 the flex power systems with the FM100 will be available. And then we also have our new circuit breakers, 300 volt rated, 40, 60, 80, and 100 amp and 125. We are providing, so the 40, 60, and 80 are available in dual pole. And okay, here we go. So in summary, we have the cost-effective solution. So the 300 volt VOC enables two string arrays to reduce the BOS and installation costs. And the 100 amp output current allows for higher power modules and arrays. So like I said before, some have the amperage, some have the voltage, but only OutBack has both. All right, well, thank you for joining, and I think we can start going into our Q&A.